In this video, we're going to look at some different representations of a proportional relationship. So suppose you make 24 ounces of Arnold Palmer by mixing 16 ounces of iced tea with 8 ounces of lemonade. So over here on the left, I have a little visual diagram of this. We can actually vary the amount of liquid in the glass. And then you can see the iced tea down in the brown on the bottom and the lemonade up top in the gold. And then there's horizontal line segments that represent the values of the number of ounces of iced tea in the mixture and the number of ounces of lemonade in the mixture. And these are for the amount of mixture that's in that actual cup. So we can vary the amount of Arnold Palmer in the cup, and those segments represent the corresponding amount of iced tea and lemonade in the cup. So, like we have previously seen, what we're going to do is actually make one of those line segments vertical. So we'll make that brown line segment representing the number of ounces of iced tea in the glass vertical, and we'll place those two line segments end to end. And then what we can do is again fill the glass. The lengths of those two line segments vary, and we place a point that lines up with both of those line segments to represent the simultaneous values for the number of ounces of lemonade in the glass and the number of ounces of iced tea in the glass. So as we vary the amount of Arnold Palmer in the glass, that point is going to move accordingly. And if you imagine tracing that point as the glass fills, we're going to get a graph representing the relationship between those two quantities. So the result of tracing that is this graph given here. So in this case, the graph is actually a straight line, which we expect to see for a proportional relationship. And any point on this graph tells us how the number of ounces of iced tea is related to the number of ounces of lemonade for some given amount of mixture or some given amount of Arnold Palmer that's in the glass. Now, let's think a little bit about how we could write formulas to represent this relationship. So, on the left over here, I have the same applet again, where I can vary the amount of Arnold Palmer in the glass, and T is representing the number of ounces of iced tea in the glass, and N represents the number of ounces of lemonade in the glass. And over here in the applet, we have the ratio of T to N and the ratio of N to T. So as I vary the amount of Arnold Palmer in the glass, the ratios of those two quantities are going to be shown here. What we're going to notice is the ratio of T to N is constantly equal to 2. So we have the ratio of T to N being constantly equal to 2, which tells us the number of ounces of iced tea in the glass is always 2 times as large as the number of ounces of lemonade in the glass, because the ratio T to N tells us the size of the amount of iced tea relative to the amount of lemonade. So if you say that enough times, the number of ounces of iced tea is 2 times as large as the number of ounces of lemonade, it should feel intuitive that we could write this formula. T is equal to 2 times N, which says that the number of ounces of iced tea is 2 times as large as the number of ounces of lemonade. And therefore, T equals 2 times N, which is a formula that expresses T in terms of N. Now, over in the applet, we also saw that the ratio of N to T, so this ratio here, it's constantly equal to 1/2, which tells us the number of ounces of lemonade is always 1/2 times as large as the number of ounces of iced tea. And therefore, the number of ounces of lemonade is always equal to 1/2 times the number of ounces of iced tea. And therefore, this is a formula that expresses N in terms of T. The graph that we looked at and the formulas that we constructed both tell us something about the relationship between T and N as a whole, or it tells us something about the relationship for all pairs of values of T and N. But if we want to just look at a few pairs of values, it's common to use a table of values to do this. So we might create a table like shown here, where we have the volume of lemonade in one column and the corresponding volume of iced tea in the other column, which just allows us to point out a few corresponding pairs of values in a nice, easy to read way, but it doesn't show us all of the pairs of values. It would actually be impossible to use a table to represent all possible pairs of values between N and T. It just highlights a few of them.